In 1950, a catastrophic earthquake violently tore through the historical city of Cusco. Grand cathedrals and proud European mansions crumbled into absolute dust within mere seconds. Yet the ancient stone foundation underneath remained pristine, unshaken by even a single millimeter.
Modern engineers force buildings to stand rigid, only to see them shatter in pride. Today, we dissect a 200-ton polygonal matrix that literally swallows massive earthquakes alive.
Welcome to the Blueprint Atlas. Prepare to unlock humanity's greatest forgotten technology.
From a structural dynamics perspective, modern mortar is actually a fatal engineering blind spot.
Cement creates an artificial rigidity that traps destructive seismic kinetic energy within walls.
The shock waves search for the weakest points, easily tearing concrete structures apart instantly.
But the master builders of Sacsayhuamán eliminated this critical structural vulnerability entirely. They completely abandoned mortar, relying instead on pure geometric locking and mass.
Massive, ultra-hard andesite blocks weighing up to 200 tons were meticulously carved.
Each stone was shaped with non-standard, complex polygonal angles that interlock seamlessly. The micro-tolerance is so perfect that a razor blade cannot slide between them.
This flawless fit is not just aesthetic. It serves an active mechanical purpose. The true genius is not how tightly these colossal stones fit together.
It is how this massive interlocking system behaves when the earth violently shakes. Why not carve simple, square stones? Because straight lines create clean fracture pathways. Instead, they utilized asymmetric polygons with up to 14 distinct spatial bevel angles. This turned the colossal wall into a massive, three-dimensional, multi-directional shock absorber. When high-intensity seismic waves hit, this giant machine does not resist the force.
The absence of rigid cement allows the 200-ton masses to shift slightly.
They separate by mere fractions of a millimeter, sliding and grinding together smoothly.
The system forces deadly kinetic waves to break across a chaotic zigzag matrix. Energy is scattered in thousands of directions, instantly neutralizing its sheer destructive power.
The violent earthquake motion is converted directly into harmless thermal energy via friction.
In structural physics, this phenomenon is precisely known as dry friction damping.
An ancient wall as solid as steel suddenly behaves like a viscous fluid.
The stones dance in perfect harmony, absorbing the shock waves with heavy mechanical grace.
No modern skyscraper can disperse energy this efficiently without advanced computer-controlled dampening. Yet, this ancient mechanism operates entirely passively, with zero electronic moving parts.
It is a beautifully simple solution to an incredibly violent physical problem.
And here is the detail that makes modern structural blueprints look utterly primitive. A reinforced concrete building accumulates internal microfractures after a major seismic event.
These hidden structural wounds remain, waiting for the next tremor to cause collapse.
However, the fortress of Sacsayhuamán is an active, self-healing mechanical architectural marvel. Those complex, interlocking polygon bevels function as highly precise three-dimensional guide ramps. When the violent ground shaking stops, gravity takes back control of the structure. The massive 200-ton weight forces each block to slide back down perfectly. They lock back into their original sockets with absolute sub-millimeter geometric precision. It uses the Earth's brutal gravitational pull to automatically tighten its own joints.
Standard history textbooks claim this civilization possessed no wheels, cranes, or iron. They supposedly carved this monumental physical matrix using nothing but soft bronze chisels. A Bronze Age society, creating a mechanical damping system of flawless geometric complexity. It makes 21st century structural engineering look like children playing with plastic blocks. We proudly believe that rigid steel and concrete can permanently conquer untamed nature.
But standing beneath these megaliths, a bitter engineering truth suddenly becomes painfully clear. Our modern concrete cities are merely fighting a desperate, losing war against physics.
While these ancient builders chose instead to sign a permanent pact with gravity. Sacsayhuamán proves they mastered extreme spatial geometry using relatively workable andesite stone. But what happens when these shadow engineers applied zero-tolerance parameters to diorite? Diorite is an ultra-hard rock that easily shatters modern high-carbon steel drill bits. Just across the Andes lies Puma Punku, where stones show no handmade tool marks. Instead, we find perfect 90-degree interior corners cut with machine-like laser precision. The narrative of bronze chisels scraping diorite is completely dead and scientifically impossible.
Look closely at these perfectly flat planes and razor-sharp geometric interlocking modular blocks.
Notice the blind cylindrical drill holes, completely smooth and consistent throughout their depth.
This level of precision requires ultra-high-speed drilling tech that we only invented recently.
A modern diamond-tipped CNC milling bit fits these ancient grooves with absolute perfection.
Yet orthodox history insists these were produced by primitive nomads without any machinery.
We are looking at concrete, physical evidence of industrial-grade precision engineering from antiquity.
An ancient, highly advanced manufacturing system whose true origin remains completely shrouded in mystery.
The next chapter of this incredible ancient blueprint is waiting right on your screen. We will dissect the impossible stone-cutting mechanics of the Puma Punku H blocks next. Digital select click.
Click on the video now to explore the next level of ancient engineering.
Before your mind tricks you into believing that none of this was possible.
Witness the forbidden machines of the ancient world. Click and see for yourself.